In type 2, our formula goes that if there are two lines, both the lines are passing through origin, then its joint equation, I can compare it with ax square plus 2hxy plus by square equal to 0. Get the value of a, get the value of h, get the value of b, and both the lines, if it makes an angle theta between them, I want the angle between those two separated lines. Both the lines are passing through origin in our syllabus. Then that angle, I can find it using tan theta is equal to, mark it up, mod 2 root h square minus ab, whole thing divided by a plus b. Let's visualize the diagram a little bit. Proof, very, very important for HSC people. CET people cancel proof, not there in syllabus. HSC people later on, I'll do all the proofs. Huh? Let's visualize the diagram. I make the XY axis. I draw two lines passing through the origin. First line, I call it like y is equal to m1x, slope is m1. Obviously, there's no c1 because passing through origin, c1 is 0. Second line is y is equal to m2x plus c2 is 0. So there's only y equal to m2x. Both the lines have an angle theta between them. Separate equations, I don't have. If I have separate equations, then there was a Levin standard formula. This also mug it up, you'll require it. Tan theta is mod m1 minus m2 upon 1 plus m1 m2. If I have m1s and m2s ka separate equation, use this formula. If you have joint equation, use the formula tan theta is mod 2 root h square minus ab, whole thing upon a plus b. Doubts, anyone with the formula, then ask me. Obviously, in the formula, if I tell you that both the lines are parallel, if the lines are parallel, then angle between them is 0 degrees. They are parallel to each other. Yeah, coincident. One above the other also, angle is 0 degrees. If theta is 0, tan theta is obviously 0. If 0 is equal to something, numerator has to be 0. If numerator has to be 0, h square minus ab is the condition which has to be 0 for two parallel lines. Numerator 0, then they are parallel. Yes.
Sir, but two parallel lines cannot pass through origin, no? Only one will pass.
So they will pass only if they are coincident. So they won't use the word parallel. Parallel means actually 3 dimension. One line is above the other line. They are parallel, but they are coincident. It is one on the other.
Okay, sir.
So both their ends are equal and coincident lines make condition h square minus ab equal to 0. What if lines are perpendicular? Two perpendicular lines. Angle between two perpendicular lines obviously is 90 degrees. Theta is obviously 90 degrees. If theta is 90, then tan theta, tan 90 is infinity. I know in maths, if I want infinity, the denominator has to be 0. So for perpendicular lines, denominator is 0, a plus b equal to 0. 3 very important formulas. एक तो tan theta का joint equation से formula, एक parallel का numerator 0, एक perpendicular का denominator 0, and one Levin standard formula. In m1, m2 is given. Angle between them is tan theta is mod m1 minus m2 upon 1 plus m1, m2. Using these formulas, let's do entire type 2. So today we'll be doing only solved examples. Then tomorrow I'll be finishing exercise type 3. For the time being, I'm not doing it because it was not there for past 2 years in the syllabus. This year it's a wait and watch. So just now, whatever is past 2 years ka syllabus, I'm taking that only relevant for HSC CET. If they tell that everything is there, then that ending parts of all the chapter, we'll be finishing it separate. So tomorrow will be the last turn for this chapter. We'll start with a new chapter day after. Our fourth chapter will begin maths. Okay, let's see the solved example first one. I have to show that lines represented by, it's a joint equation because it's a quadratic. Compare it with ax square plus 2hxy plus by square equal to 0. Obviously, a is equal to 3. Obviously, 2h is minus 4, so h is minus 2. Obviously, b is equal to minus 3. I have to prove it is perpendicular. Tan theta ka formula, mod 2 root h square minus ab upon a plus b. If theta is 90 degrees, tan 90 is infinity, denominator is 0, a plus b, if I add up, 3 minus 3 is obviously 0, hence they are perpendicular. Doubts in super important question 1. Any doubts? Question 2. Show that these lines are coincident, one above the other. Coincident, parallel, one on the other one. For that, angle between them is 0 because they are one above the other one. If theta is 0 degrees, tan theta is 0. Tan theta ka formula is mod 2 root h square minus ab upon a plus b. Tan theta is 0, numerator is 0, h square minus ab I'll calculate. Uska answer should come 0. It is coincident. I'll compare it with ax square plus 2hxy plus by square 0. Obviously, a is 1. 2h is 4, so h is equal to 2, b is equal to 4. आराम से properly calculate h square का 4 minus a into b is 1 into 4 is 4. 4 minus 4 is 0 because h square minus ab is 0. They are coincident. Super important question 2. Doubts? Anyone with these questions that ask? And the third one is to find the acute angle theta between two lines whose joint equation is given. I'll tell you on the first one, all the rest are same. Compare it with ax square plus 2hxy plus by square is 0. I get a as 1. 2h is equal to 1. So h is half. I'll get b as 0. I use the formula tan theta is mod 2 root h square minus ab upon a plus b. Shanti se barabar se substitute karo. Carefully simplify the whole thing. Get the answer of tan theta. Use your school ka tans. Tan 0 is 0. Tan 30 is 1 by root 3. Tan 45 is 1. So theta is 45 degrees. Had it been root 3, then tan 60 is root 3. Had it been infinity, then tan 90 would be infinity. Convert degrees to radians, get your answer. All these are super important HSC CET questions. Doubts any? All 5 parts are same, so properly solve them. If they are non-standard angles, like the fourth one, 2 root 7 upon 3, so leave the answer like that. ABCD option mein, it will be in this format only. Tan inverse 2 root 7 upon 3. Start with example 4. Find the combined equation of lines. They are passing through the origin. They are making. Classic question. Very important question. Generally in your CET paper, either you'll get this example 4, Yeah, example 5, or you'll get the question from the exercise of the previous one, the first exercise. 2 questions generally will come in your CET paper from this chapter, and it is fixed, either example 4, 5 या उसका unsolved में से या ऊपर का exercise में से. Always from 90% is from those only question, 10% is the other easier questions में से it can come. Okay, so see the super important question, very, very important for CET. They are saying, I want the combined equation of a line. The lines, both lines are passing through origin. Both the lines are making 30 degrees with another line. So if I call M be the slope of one of the lines, which is making 30 degrees with this given line. For the given line, I can make y the subject of the formula. Y is equal to minus 3x plus 6. If I compare with y is equal to m2x plus c2, because the required slope, if I call it as m1, second line ka m2. I got m2 as negative 3. I have my 11th standard ka super important formula. Tan theta is mod m1 minus m2 upon 1 plus m1 m. Clearly, they have given theta as 30 degrees. I know tan 30 is 1 upon root 3. Let's call m1, which is the slope of one of the lines, as m only, and m2, that 30 degrees it is making with the second line m2, jiska slope you got as negative 3. So take m1 as m, take m2 as negative 3, cross multiply it. To remove the mods, you are going to square both the sides. Squaring both sides always removes mod in math. So square both sides, expand the brackets, make it into a quadratic equation in M. Doubts? Anyone can answer. We had done in the previous exercise that a quadratic equation in M was given a name auxiliary equation. CET people don't have to mug up all these names and all. HSC people, yes, you have to write that this is the auxiliary equation for the required combined equation. CET people mein, we used to do ulta, we used to take y is equal to mx. So wherever there was y upon x, we used to put it as m. But now m equation is there. So wherever there is m, you will replace y upon x because you want y and x make combined equation. I will take x square ka LCM. I'll get 3y square minus 12xy minus 13x square is 0. Take it on the other side and get the final answer of the combined equation. I repeat the procedure, properly understand the procedure, CET. These are your sure CET questions. The previous exercise and these two solved examples. So you want the combined equation of lines. Both the lines, x square, y square, mein, joint equation, both are passing through the origin. So it's of the form ax square plus 2x square plus by square is 0. But they have not given that, you want the combined equation. And they have said that the lines are making 30 degrees with another line. So since the lines are making 30 degrees with a second given line, actually a third given line, then theta is 30 degrees. This line may you make y the subject, get m2 from that. Let m be the slope of those lines which make 30 degrees with that third line. And use the formula tan theta is mod m1 minus m2 upon 1 plus m1 m2. Put m1 as m, put m2 as negative 3, cross multiply, square both sides, remove the mod, make a quadratic in M, put M as y upon x, take the LCM, get your joint equation. Doubts? Anyone with this very, very, very important question then ask me. Next question. Fifth. Procedure properly you'll have to remember. Fifth, again, I want combined equation. Again, both the lines are passing through the origin. And again, they are making 60 degrees. But this time they are making 60 degrees with a line, which is the x-axis itself. I know that in x-axis, it's a horizontal line. Its angle with the x-axis is 0 because you are taking the x-axis itself. So theta is 0. Theta is 0. So tan theta is m2. Tan 0 is m2. M2 is 0. Tan theta is mod m1 minus m2 upon 1 plus m1 m2. I will take theta 60 degrees. I'll take m1 as m, like we did in the previous question. Take m2 as 0, cross multiply, square both sides, make a quadratic, replace m as y upon x, take the LCM of x, and get the combined equation. Doubts anyone with these super important example 4 and 5? Then ask me. Yeah, so you can start solving with the solved examples. First, write down all the formulas, 4 formulas to be written. Take tan theta is mod 2 root x square minus ab upon a plus b. Parallel line stuff, x square minus ab is 0 of the numerator. Perpendicular lines make a plus b of the denominator is 0. And one 11th standard formula, tan theta is mod m1 minus m2 upon 1 plus m1 m2. Write the 4 formulas. Start with the 5 solved examples. Any doubts, anything? Tomorrow offline lecture may also we'll be doing till solved example 5. Then tomorrow I'll explain the exercise and we complete the chapter. Yes, I'll disconnect for today. Meet people, J people will join at 6 o'clock for chemistry and other people you can start. So, okay, I'll disconnect.
Bye, sir. Thank you.
Okay.